Okay, this is lesson 9.4. This is not difficult, but it is a couple of different steps. You're just going to have to practice, okay? Okay, let's go ahead and go over the warm-ups. 3x minus 6 equals 4x minus 12. That's going to give me 6 equals x. 6 is natural, integer, whole, rational, and real. My slope here is going to be 5 over 4x minus 5. So my slope is 5 over 4. That is a rational and real number. It's a fraction, so it is not an integer. I see real with no equal sign. That means infinite. Okay. Today, we are going to talk about... Okay. We're going to simplify square roots. Okay. Now, there are such things as perfect squares. 49 happens to be a perfect square. A perfect square is when a number multiplied by itself, it gives you an answer. Like, for example, 2 times 2 is 4. So, the square root of 4 is a perfect square. It's 2. 3 times 3 is 9. So, 9 is a perfect square. It's 3. 4 times 4 is 16. So, 16 is a perfect square. It's 4. Because 4 times 4 gives you 16. The square root of 16 is 4. Do you see how we're dealing with pairs of numbers? 5 times 5 is 25. 6 times 6 is 36. Onward and upward. So, when a number is a perfect square, you don't have to do anything except write equals 7. Because 7 times 7 is 49. That's a perfect square. Now, when you get into a number like 125, 125 is not a perfect square. So I need to make a factor tree. On the left side of your factor tree, you want prime numbers. Prime numbers are numbers that only one and that number will go into. For example, 1 is prime because only 1 goes and 1 go into 1. 2 is prime because only 1 and 2 go into 2 evenly. 3 is prime because only 1 and 3 can go into 3. 4 is not prime because 1 can go into 4, 2 can go into 4, and 4 goes into 4. However, 5 is prime because only 1 and 5 go into 5. Those are your prime numbers. So on the left side over here, I'm looking for prime numbers. 2 and 3 will not go into 125. 4 is not prime. 5 goes into it. 5 goes into 125 25 times. 5 goes into 25 5 times. There is my factor tree. 5 times 5 times 5. 5 times 5 is 25 times 5 is 125. Now I'm looking for pairs. I have a pair of 5s. So these two become 1. The pairs become 1 because we're dealing with square roots. It's like they get married and the two become 1 and they move out of the factor house. Now, what is left inside the factor house? Well, that 5 has to stay inside the factor house because it doesn't have a pair to move out with. We still have something else here. We also have the x squared. X squared is x times x. That is a pair. The two become 1 and move out, so 1x moves out. So my answer is 5x square root 5. Okay? Let's try and look at number 5. Number 5 is the square root of 5 16th. So this is the same as the square root of 5 over the square root of 16. Now look at number 6. This is just the square root of 44 over 6. So 6 is not in my square root. 6 is just 6. So let's go back and deal with this. 5 is prime. If the number inside your square root is prime, you can't do anything with it. So this is going to equal the square root of 5 over 16 is a perfect square. 4 times 4 is 16. So it's the square root of 5 over 4. Okay? Over here, 44 is not a perfect square, so I'm going to have to factor that. So I'm going to factor 44. 2 goes into 44 22 times. 2 goes into 22 11. 11 is prime. Nothing will go into 11 except 1 in itself. So here I have a pair of 2's. So they're going to move out of the factor house. So I'm going to have 1, 2 out of the factor house. But inside my factor house has to be the 11. And 6 stays on bottom. Now, I can reduce 2 over 6. It reduces to 1/3. So this reduces to 1 over 3. Keep your factor house with 11 inside of it. This is your answer right here. Okay? Let's look at number 7. Let's look at number 7. Now, I have a negative 1/2 outside. I don't do anything with that. I first factor my 56. 2 goes into 56. How many times? 2 times what is 56? 28. Thank you. 2 can go into 28. How many times? 14. 2 can go into 14. How many times? 7. Everything on the left is prime. That's what I want. So, okay, so I have a pair of 2's. Those 2's are going to move out. Now, what's already outside of the house? The negative 1/2. And I have 1, 2 times 1, 2, because it came out. What stays inside? 2 times 7. What's 2 times 7? So I have the square root of 14 right there. Okay? Now, negative 1/2 times 2. What's negative 1/2 times 2? Negative 1 square root of 14 is your answer. Okay? Okay. So, only do the square root of 12. The square root of 12 is going to be 2 times 6, 2 times 3, so it's going to be 2 square root of 3. 2 square root of 3 over 36. 2 over 36 can be reduced to 1 over, what's half of 36? Half of 36 is 6? How about 18? Square root of 3, okay? Okay, let's look at number 11. The first thing I'm going to do is I'm going to go ahead and factor the 64. 2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. So I factored all the way down as low as I could go. So there's a pair of 2's. There's a pair of 2's. There's a pair of 2's. So it turns out that 64 is really 2 times 2 is 4 times 2 is 8. So 64 is a perfect square. It's 8. Okay? So now, I have 16 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How many pairs do I have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 x's can move out. Now all I really had to do was cut 16 in half. So all I have to do is cut 2 in half. I have 2 y's, that's 1 pair, so 1 y comes out. That's my answer. Okay? If I had, here we go, 36 is a perfect square, it's 6. Now, 4 divided by 2 is 2, so 2 x's come out. Now, 7 divided by 2 is 3 with a remainder of 1, so 1 y has to stay in. Okay? If you have any questions, please feel free to come in and ask. Have a nice day.